So when it comes to reprocessing spent fuel or the recycling process, this is a radiochemistry sequence. In other words, you actually take a spent fuel bundle, you'll chop it up into bits, and you dissolve it in very concentrated, high temperature acid. That turns the whole thing into a solution. What then takes place is what we call titration. Titration is where you change the pH such that certain chemical species will precipitate out or stay in solution. And you'll do this titration, taking out certain elements as you go, such that in the end, you're able to remove the actinides, basically the plutoniums and the uraniums and the americiums and so forth, from the rest of the fission products. The fission products themselves will have, on average, a much shorter half-life than the actinides. Something on the order of decades is typical for the longer-lived ones, specifically cesium and strontium. With that, the actinides, the uranium and the plutoniums, you could further separate those if you want, or you could just leave those together. There are two different processes for doing this. And then that uranium and the plutonium could then be used in additional fuel. So rather than doing enrichment, which has its own set of issues for proliferation and so forth, you could bi-step enrichment and use this actinide, plutonium, and uranium mix with natural uranium to have a fuel cycle that does not require uranium enrichment. Now, I'm not trying to say that uranium enrichment is bad. I'm just pointing out that there are issues like what's taking place with Iran right now. And so the benefit there is that by removing those fission products, you're able to take the longer-lived actinides like the plutonium and turn them back into fission products that have a very, very short half-life. So the whole process really is just chemistry. It just requires a lot of very fine tuning of the chemistry because those actinides, they have multiple oxidation levels. In other words, you could be, say, at a +1 or a +2 or a +3 or a +4 or negative states. And so each of them is very sensitive to the way that you treat it. But the point is that we know how to do it. It's been done. Many countries do that. The United States isn't doing that right now. Even though the United States developed the technology, other countries are doing it. And if we started doing it again, we could improve it vastly if we decided to invest in research to improve that, to make it safer, more cost effective, and so forth and so on. So I hope that helps. It really just does come down to a chemistry process, much like recycling of other things. But with spent fuel, there are a lot more safety issues that you don't have with other industries. So we know how to do it, and we can actually do it quite well, and we could even do it better if we chose to do it. So I hope that helps. Thanks.